Hi everybody, today we are doing a big note, this might be a long video, um, about solving linear systems by graphing, word problems, and decision making. So it's really important that you understand that there are situations where looking at a graph is more helpful than just finding an algebraic solution. If you're looking, for instance, to make a decision, that's why there's decision making in the title of this note. You might want to know when something's cheaper or when you're going to be earning more money. So to be able to compare what's going on over what intervals, graphs can be very useful. Now, I have decided that I want you to get more used to graphing using Desmos. So I do encourage you to, oops, I already started this stuff. Better get rid of that. To have Desmos open. So you go to desmos.com and you hit start graphing. And then you get to this graph, okay? It'll actually be much more zoomed in when you first swipe to it. Something like this, actually even more. So I guess I should just go to the default, okay? It'll probably be like that. All right, so let's get started. So I will be doing some of the work on the handout, and then some of it I'll be switching over here to Desmos. So you should pay attention how I'm actually making the graphs. Or another strategy is on the side here, you could put the time in the video, like at 5:47, Mrs. Ween starts making this graph online. So then later, if you want to refer back to the video, you could just go right to that spot. That's another technique. Okay, so this is we start very basic here with Brian and Catherine who want to get internet for their home. So there's two companies in the area and they want to know which is cheaper when, right? You want to help them decide when to choose each company. So IT Plus, we'll start with them, charges a flat rate of $25 per month for unlimited use. But Techies charges only $10 a month, but then $1 per hour. So first of all, what I want you to understand is that we are going to be comparing, make a little, see, why does it do that? Anyone have an idea? You let me know. Something with the trackpad. Okay, back up to the question. Okay, so something I want you to make sure you understand is that we are actually comparing the monthly cost here. So the number of months is not a variable because you're comparing how much would they spend on a given month. So no, we're comparing monthly cost, therefore month is not a variable. Just want to make that really clear. So what is a variable then though is the number of hours of use. So let H represent number of hours, and we'll say let C represent monthly cost in dollars. Okay, so we have two equations. One of them is IT plus. So IT plus, so its cost is just $25. There's actually no variable H there because no matter how many hours you spend, it's 25 bucks. So it's just a flat line. Then we have Techies Inc. and their cost is $10 a month. So there's the $10 flat fee for the month and then $1 an hour. So you could put a 1 there in front of hours, but you don't need one. Okay, so if we use algebra to solve this, we would set the two equations equal to each other. So we would have 10 plus H equals 25. Subtract 10 from both sides, you get H equals 15. So let's think about what that means. That means that at 15 hours, they both cost the same. Either plan would cost you the same amount of money. So how does a graph help you here? Well, a graph will help you find out when each one is cheaper. So it's more valid to say, well, less than 15 hours, you should choose this, and more than 15 hours, you should choose this. So I want you to go ahead and graph it here. You can do hours and then cost up here. So I did a scale of 1 on the bottom. So 1, 2, etc. And then I went up by, you can go up by 5 every other one. So like 5 here, 10 here, 15, 20, 25, 30, 35. Okay, so I'm going to show you on Desmos how this will look, and then you can also put this on your graph there. So our first equation is C equals 25. Now Desmos always uses Y and X, so instead I'll just put Y equals 25. Oops, my cap's wrong. Y equals 25. Okay, so you can't see it. So what does that mean? Well, think about it. Y equals 25 means that Y is 25. So I can't see it because it's up here. So this is the graph Y equals 25. If I want to turn it off, I can, or I can turn it back on. So there it is, Y equals 25. Now my other one is Y equals 10 plus H, but I'm going to make it 10 plus X. Okay, so that's what it should look like. So you start at 10, and then when you go over 1, you go up 1. Now that only works though if you're in a 1-to-1 ratio. So it might make more sense for you to actually plot this point 15, 25, which is, is going to be the point of intersection. Now, what's great here is that with Desmos, you can actually touch that point of intersection and it will tell it to you. So looking at this graph, you can see that for less than 15 hours, this red line is cheaper. So that belongs to Techies Inc. So if you're using the internet for less than 15 hours, Techies Inc. is a better choice. If you're using the internet for more than 15 hours, then IT Plus is a better choice because they're cheaper. So that's how using a graph can be helpful. So again, here the 1 would just be a flat line at 25 with the ruler, and you can label that IT Plus. And then the other one would start at 10, since that's the y-intercept. And the slope is 1. However, you can't go over 1, up 1 on the grid squares because each of these grid squares represents 2.5. But you could go over 5 and up what 5 is here, which is 2 grid squares. Okay, and you'll also get eventually that they will intersect at 1525, which is here. So again, this is why I'm not really focusing on my hand-drawn graphs because I don't have a ruler. But that's what it would look like, and you could label that Techies Inc. And then you would label this with the point of intersection 1525. So you need to write a sentence for Brian and Catherine. So you can say if you use the internet less than, I'm doing it very short form because the trackpad's a bit annoying. So if you use the internet less than 15 hours, choose Techies Inc. But more than 15 hours, again, you should be writing full sentences. Choose IT Plus. Okay, so that's our very basic kind of question with graphing. We're going to go with the same situation, but a bit of a different idea. It's going to throw a bit of a wrench into things. So in this case, IT Plus has changes their plan. Okay, so they no longer just have the $25 no matter what deal. People are maybe taking advantage of it. So we'll still say that our variables are the same. So let H represent number of hours, and let C represent monthly cost in dollars. All right, so, well, actually, let's start with Techies Inc. here because they're still the same. So Techies Inc. is still the cost is $10 plus $1 an hour. So that's our first equation. Okay, but IT Plus has done something weird. They charge $25 for the first 50 hours and then $1.50 for each additional hour after 50 hours. So when you have a situation like this, you actually have to represent this equation with two equations. It's called a piecewise function. So for IT Plus, their cost is $25, comma, for all H less than or equal to 50. So if H is less than or equal to 50, you still have that straight horizontal line at 25. However, if we're more than 50 hours, then they charge the $25 plus $1.50. Now here's where it gets tricky. A lot of people want to write this, $1.50 times H. But what's the problem? If you use 51 hours and H is 51, then you would be charging $1.50 times 51 hours. That's not what you want to do. If you use 51 hours, you only want to charge the $1.50 for that one extra hour past 50. What about if you use 70 hours? Again, if I had this equation, if H was 70, I'd be charging the $1.50 for all 70 hours. I don't want that. I only want to charge it for the 20 hours that are above and beyond the 50. So how we get rid of this is we have 150 bracket H minus 50. So you take whatever the hours are, so like 51 hours, and you subtract 50. 51 minus 50 gives you 1. So you only charge $1.50 for any hours past 50 hours. It's very important to understand. And this is true for all H greater than 50. So we can simplify this equation. Okay, you would get 25 plus 1.5 H minus 75. So 1.5 H minus 50. Okay, so let's take a look at what this looks like on GeoGebra. And I want to teach you guys how to put these types of piecewise functions onto GeoGebra, the functions with two parts. They come in two pieces. I actually like to call them Mennonite functions because they're piecewise. Get it? Wise at piece. Anyways. All right, so Techies Inc. is just y equals 10 plus x. So again, you put everything back to y's and x's. So that's our Techies Inc. Okay, so now we're going to do IT plus. So we're going to do y equals 25, but I only want it to be up to 50. So I put a curly bracket, which is above your square bracket. On my keyboard, it's right next to the letter P. And then I put X, and then down here, I choose less than or equal to 50. And I end the curly bracket. And I press enter. So notice how it stops here at 50. Then I put y equals my other equation. So I can actually do it without the rearranged version. So I can do 25 plus 1.5 bracket x minus 50, end bracket. Then I start my curly bracket. X is greater than 50. Enter. So take a look here. So the green and the purple line are both IT plus, and the blue is Techies Inc. So notice that it still intersects here at 1525. But look at what's happening with the blue and the purple line. They look like they might be connecting together at some other point. See how they're getting closer and closer together? So we actually have to zoom out and notice that our decision involves a lot more minutes. There's another point of intersection up here at 120 hours. Okay, so now we have 3 sections that we care about. So for here, up to 15 hours, Okay. For 0 to 15 hours, this blue line or Techies Inc. is the best choice. Okay. Then from 15 hours up to, what's the point there? 120 hours, IT Plus becomes the best choice. But after 120 hours, guess what? Techies Inc. is the cheaper one again. So there's actually 3 sections that you have to consider. And that's what happens when you get these two-part equations, which are called piecewise functions. That's what happens when you get this function or this equation in 2 parts. So you really have to zoom out to be able to see this properly. So for you to graph this here, okay, so you know you need to get up to past 120. So I went up by 10. So it's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 120, and then 140. Okay, so this is hours. And then for cost, I also went up by 20s. So by 10s. So 10, 20, 40, 60, 80, 100, 120, 140. Okay. So my Techies Inc. started here at 10. And then the slope was 1. So if I went over, see, why does it do that? So if I went over 20, then I should go up 20. Okay, if I went over 20, I should go up 20. Okay, and I know I have 120, 130. I know that that's a point. You know, you can just make a table of values to come up with points, but you should be using a ruler here. And you can label this Techies Inc. Okay, now with my other guy, I know that I have this solid line at 25, which is about right here. There we go, up to 50 hours, which is there. And then I start sloping up at a rate of 1.5. I don't know why these lines keep going away. But I know I intersect here at 120.30. So I'm just going to use that to eyeball this. Okay, it should be intersecting here at 120, 130. And then we have this intersection here, which is 15, 25. So now you need to write your nice sentence. So if your hours are less than 15, you choose Techies Inc. If you're between 15 and 120 hours, you choose IT Plus. And then for hours over 120, you choose Techies Inc. again. But you can write some nice sentences there. Okay. So you might be wondering, well, Mrs. Wiens, how can I make sure that these numbers are exact? Like, how would I know that it's exactly 15 and 25? Well, you can still use algebra to find the points of intersection. So to find the first point of intersection, let me call this equation 2a, and let me call this one equation 2b. So to find the first point of intersection, you would set 1 equal to 2a. And that is where those two sections meet. And then to find the second point of intersection, you would set 1 equal to 2b and see where they meet. And that would find this point of intersection. That will also help you determine the scale before you go and solve it. If you actually solve it algebraically, it will help you determine the scale before you graph it. All right, let's go on to another example that is similar to the one we just did. Okay, so Mrs. Wiens is trying to decide what daycare Emmett should attend. Toddler time costs $150 a week for any time up to 4 hours And then after 40 hours, charges $5 an hour. Sylvia's day card charges just $4 an hour. Okay, just whatever. So which one should I choose? Well, first of all, we should understand that we should just be comparing the weekly cost of daycare, okay? Not the, so week should not be a variable. So we have, let H represent number of hours. Sorry. I pushed a little button here. Okay, there we get that out of there. Number of hours. And let C represent cost in dollars. Okay, there should be a rep there. Okay, so let's look at toddler time. So toddler time has this two-part equation, right? So toddler time, its cost is just $150 for any H less than or equal to 40. But then that cost becomes $150 plus $5 for any hours greater than 40. So I have to take off the 40 to make sure that the H is only being charged for any hours past 40. And this is for H greater than 40. Okay, so I can call this equation, back to this. This is equation 1A, and this is equation 1B. Okay, now notice that the equation again can be simplified. So you would get C equals 150 plus 5H minus 200. So C equals 5H minus 50 is a simplified version of 1B. Okay, now let's do Sylvia's daycare. So hers is relatively simple. It's just C is equal to 4 times H. So 4 times the number of hours. So this we can call equation 2. So let's think about what this is going to look like. Toddler time is going to be a flat line at 150 until it starts going up by $5 an hour. Whereas Sylvia will just be an angled line with a slope of 4 for the entire time. So how can we find when these two will intersect? Well, we can find the point of intersection between 1A and 2. And then we can find the point of intersection between 1B and 2. So in this example, just to show you a different method, I'm actually going to do that first. So 1A is $150. And we want to know when that equals 4H. So to divide that, you get, what is that? 4H equals 150. You get H is equal to 37.5. So at 37.5 hours, they'll both be $150. Now I can set this 1B, so this 5H minus 50 equal to 4H. So I can add 50 to both sides and take this 4H over. You end up with H equals 50. So at H equals 50, they cross over again. So why is this helpful? It's helpful because now I know kind of what scale I should be thinking about. They intersect at 37.5 hours and at 50 hours. So I know that on my scale down here, I need to go up to at least 50 hours and past it would be preferable so that I can actually really see the points of intersection. Now on my vertical axis, I know that I'm going to have $150, but at 50 hours, I can think, well, that would be $200 for Sylvia's daycare, right? 4 times 50. So I know I need to go up at least to $200, if not more. So I chose a scale of going up every other one by 5 on the bottom. So every other one was 5. So 5 and then 10 and then 15, etc., etc. That's number of hours. And then for my cost, I went up by 10. So 10, 20, 30, 40, etc. And you get to 200 up here. So I can graph this relatively, so really you should label all those. So I can graph this relatively simply. So Sylvia's was red. So at $0, she's at 0 hours. I know that. And I know that at 50 hours, she's at 200. So I'd have to keep going up. So at 50, so 20, 25, 20, 30, 35, 40, 45, 50. So at 50, she is at 200. Okay, and she starts at 0, 0. Now, ideally, I'd put more points along the way. That's what I'd recommend. I cannot believe that just disappeared. Okay. And there you go. You have your, right? That's Sylvia. Okay, and then for the other one, toddler time, you would have your straight line at 150, wherever that is, and then it would start going back up and it would intersect here. So it would end up looking something like this, you know, except everything would be done properly. Now, the reason why I'm not doing this in more detail here is because I want to show it to you on Desmos. Okay, so let's change these equations now. So you can just press the X's to get rid of those. So let's do Sylvia's first. So hers is just y equals 4x. Okay. Now toddler time has y equals 150, curly bracket, for x less than or equal to 40, end my curly bracket. And then y equals, what is it? 150 plus 5 times x minus 40, curly bracket, for all h greater than 40. Okay, now obviously you can, oops, I didn't mean h there, my x. There we go. Okay, so notice that you cannot see this here. So one option is just to kind of scroll out and around until you can see what's going on. Or another option is to go to the graph settings here, and you can change what the lowest that you see on the x and what the low and the highest is, and the lowest and highest on the y-axis. So I'm going to change this where the lowest x here that I see is just -5. Okay, because I want to see a little bit to the negative. I don't want to just start right at 0. And I want it to go, let's say, maybe up to 70. Now for my y-axis, I also want to do -5. And I know that I need to go past $200, so let's say $220. Okay. And then there, I have a nice view about what's going on. So you can see that here's the point of intersection, and you can click on it, and it will tell you that at 37.5 hours, it's $150 for both. So less than 37.5 hours, this black line, or Sylvia, is the least expensive. Then in this section, until we meet this point of intersection at 50, toddler time is cheaper. So if I need daycare between 37.5 and 50 hours, I would choose toddler time. But again, if I go past 50 hours, then Sylvia's daycare becomes cheaper again. Okay, so that's been quite a lot today about graphing and making decisions. So the rest of the examples either we'll do in class, or I'll make a separate video I'll just see what I decide to do. But that is a good starter. So what I want you to make sure you know how to do is how to create these two-piece equations when there's more than one way. So when they go like flat and then up, how to be able to find the multiple points of intersection, and then how to use a graph, how to graph it and make decisions. So you should learn how to use Desmos to graph, and you should also be able to graph by hand. So that's what you should know as a result of this video. So thanks for watching. Hope you learned lots.